Hey guys, we started section 10.3 a couple of days ago, and you had an assignment that was just the front page of this worksheet 10.3. You did operations with radical expressions. Our goal is the same today, to simplify products and quotients of radical expressions. The other day in class we just did sums and differences, adding and subtracting. So ones that had like radicals, and we added and subtracted things like this. So in class today, we're going to move on forward, and we're going to multiply. Now, some of you might have already seen some of these multiplication ones. I think I got a little bit farther in one or two classes on Tuesday, but it's not bad to review this again. So if we're going to try to multiply here, like the square root of 10 times the quantity, the square root of 6 plus 3, it works exactly like the distributive property that you've learned before. So we're going to distribute that square root of 10. When we do that, since they're both under a root, we get to write them under that root again. So 10 times 6 gives me 60, the square root of 60. Okay, plus 3 times the square root of 10, which 3 is not under the square root, 10 is. We cannot multiply those both under or outside of the root. They have to stay where they are. The 10 under the root, the 3 outside. Okay, so now I have the square root of 60 plus 3 times the square root of 10. So I'm not quite done yet, because the square root of 10 is just 2 times 5. There's no perfect squares. The square root of 60, we need to make sure there are no perfect squares in that square root of 60 in order to simplify that. So the square root of 60, we know it's divisible by 2. 2 times 30, but 30 is also divisible by 2. So we know the square root of 60 is actually divisible by 4. So when we break this up, we're going to have 4 times 15. So the reason I chose 4 is because it's a perfect square. Plus 3 root 10. Okay, so now we can simplify, and we know how to do that. The square root of 4, since it's a perfect square, the 2 comes outside the radical, times the square root of 15 plus 3 times the square root of 10. Alright, if these were both like radicals, the square root of 10, the square root of 10, or the square root of 15, the square root of 15, I could add them together, but they're not. This is the square root of 15, that's the square root of 10. They're both simplified as far as they can go. 10 is just 2 times 5, 15 is 3 times 5, and so that's all we can do here. That's your final answer. Okay. Some of them you might have that look like letter B here. For this one, we've done this before. We called it foiling, or multiplying a binomial by a binomial. And that's exactly what we're going to do again. So when we did that before, we distributed the square root of 6 times the square root of 6. So we're going to do that first, and we get the square root of 6 times 6 is 36. Distribute that square root again, the square root of 6 times the square root of 3. Those are both under your radicals, so it's 6 times 3, which is 18. We're going to keep on going. We already distributed root 6, so we're going to distribute negative 2 root 3. So that one's definitely negative. The 2 outside of that radical does not have anything to multiply by in the second one. So that's just 2 times the square root of 3 times 6, again, is 18. And finally, negative 2 times the square root of 3 times the square root of 3, again, is negative 2. Root 3 times root 3 is the square root of 9. Okay, we have some simplifying to do, because the square root of 36 is actually 6. And we have plus, and remember, you can stick a 1. 1 times the square root of 18. Minus 2 root 18. So you have 1 root 18, 2 root 18 is negative 1 times the square root of 18. We're just kind of like combining like terms. Minus 2 times the square root of 9 is 2 times square root of 9 is 3. Alright, we have a little bit further to go. So 6 minus, alright, the square root of 18, we don't need this 1 there if we don't want to write it. The square root of 18, I definitely see a perfect square in 18 with 9 times 2. 9 is a perfect square. Minus 2 times 3 is 6. So what we're going to do now is combine like terms, and 6 minus 6 just gives me 0. Oh, so the only thing that's left is this negative square root of 9 times 2. Well, the square root of 9 is a perfect square. It's 3. And what's left under your root is a square root of 2. And so that's your final answer. We're all simplified, it's all cleaned up, and we're done. Okay, so I want to give you a little bit of time to try this out. I want you to try number 7 on your own. And so just give me a pause for about a minute and give it a good try, and then hit play, and we'll check your answer. Okay, time to check your answer. So we distributed the square root of 3 times the square root of 5, and they're both under a root, so we can multiply them together and we get the square root of 15. That was this first distributing. Then we're going to multiply the square root of 3 times the square root of 3, which is the square root of 9. So the square root of 15 has just 3 times 5, no perfect squares, but the square root of 9 is actually 3. So we simplify that. The square root of 15 plus 3. There's no more simplifying we can do, nowhere else we can go, so that's your final answer. You can go ahead and cross off conjugates from your Fourier model. So let's get your Fourier model out. Go ahead, get it out, and then just erase or cross off conjugates, that word. We do not need this word in our Fourier models anymore. We're going to actually skip this piece. So I just want to make sure you can free up that space to put something else in there. And so we're also skipping everything to do with conjugates to make this a wee bit simpler. And on your homework assignment, so we already did this 10.3, the first page here, which was 1 through, I want to say, 15 or so. So we're going to go ahead and finish the back page. 1 through 10 we did. We're going to do 11 through 21, it looks like, for the rest of your assignment. So that's what's due for Friday. So go ahead and get that out. You should have more than enough time to finish in class here. So go ahead and finish that up.